So in this tutorial, I just want to go over something called a reaction mechanism, which so far we've only gone over overall reactions, but the problem is a lot of reactions actually take place over several steps. And it's not just one full, you add two reactants together and they form a product. There are times where you actually have to do several reactions in order to be able to get to that overall reaction. And these steps are known as elementary reactions. And we'll get into this a little bit more within the next couple of tutorials. As far as a reaction mechanism, it's just basically that set of reactions required to be able to get to the overall desired reaction. Now, each mechanism contains what are called reaction intermediates, where they don't appear in the final equation, but they are needed throughout the different steps that you have. And I'll give a more specific definition for that a little bit later. So let's just go through how to figure out our overall chemical equation if we were given a reaction mechanism. So for instance, in this case, you'll notice that you have three different steps, and those three different steps will make one chemical equation, and that's what we're trying to get to. So what you should probably do first is figure out what you can get rid of, and going back to Hess's law, if you remember back to that. With Hess's law, you know that if you had substances on opposite sides of the yield arrow, you're able to get rid of them. And if you had substances on the same side of a yield arrow, you're able to add them together. So that's what we're basing this on as well. So for instance, in this case, if you look up here, you'll notice that you have two Cl's. And then if you keep going throughout the rest of the steps, you'll notice that you have a Cl here and a Cl there. So basically you have a total of two Cl's on this side. They're on opposite sides of the arrow though, so you are able to get rid of them. So just cross those out. And then you can keep going with this as well. If you notice that you have a CCl3 here, you have a CCl3 there, opposite sides of the arrow, so you're able to get rid of those as well. So now just write out what you have left. So you have Cl2 plus CH, Cl3 yields HCl plus CCl4, like that. Anything that you crossed out, those are known as reaction intermediates. And then here's your overall reaction for this, and that's how you're able to get it from the reaction mechanism. So let's just go through another example. In this case, you have H2O2 and H2O2, but they're on the same side of the arrow, so you're going to have to add those together. And then if you go over here, you'll notice that you have an H2O and H2O, same side of the arrow, you'll have to add those together as well. But for now, we'll ignore those. Let's just go through and try to figure out what we can get rid of. So in this case, you have an I negative here, and then you have an I negative there. Opposite sides of the arrow, so you can get rid of them. You have an IO negative here, IO negative there. Opposite sides of the arrow, so you can get rid of them. So now just write out what you have left. And again, like I said, the H2O2s on this side, they're on the same side, so you can add those together. So you end up with that. And then the two H2Os, same thing, on the same side of the arrow, so you can add them together. And then you're left over with an O2. And that would be your overall reaction for this reaction mechanism.